WebRTC stands for Web Real-Time Communication. What is and why WebRTC? Let me make sure that I'm actually recording it. Yeah, good. We are doing recording. Okay. So these are the topics that we are going to talk about. So we will see what is and why WebRTC, and then we are going to actually spend most of our time learning three programming APIs: media stream, and RTC peer connection, and RTC data channel. And we also talk about the concept of signaling, which is actually basically a mechanism for connecting users. So what is and why WebRTC? So this is the list of these are the visions of WebRTC. So basically we want to have a common communication platform for all kinds of devices, including phone, TV, computer. So everything can communicate in real time. Okay. So basically it should be easy for any web application to add its own Skype with very simple few lines of code. Okay, so you can add any video chat and peer-to-peer data sharing. So Skype, as well as the peer-to-peer data sharing capability to your web application with a few lines of code. Okay, so that's the visions of WebRTC, and that's what is possible right now. So need for open standard RTC. So before WebRTC, there are in fact some technologies such as Skype. And in fact, the Facebook is using Skype underneath, and Google Hangouts. So these are the technologies that are provided in a form of special plugins. And downloading and installation of these plugins are not really easy, and they are error prone, and so basically a lot of the incompatibilities as well. So we need something standard in this area. So that's what WebRTC is all about. It's a standard real-time communication platform. Okay, so WebRTC is free, open project which enables web browsers with real-time communication capabilities with a simple JavaScript APIs. Pretty straightforward and simple definition of WebRTC. So if you compare WebRTC against WebSockets, they have a different goals. WebRTC is for providing the communication infrastructure, communicating platform for real media communication, real-time media communications, while WebSocket is actually for providing reliable bidirectional real-time data communication. Okay. In fact, you can build WebRTC on the top of WebSocket, by the way. Right? Architectural differences. WebSocket requires server to act as a middleman, meaning WebSockets are typically between client and server, right? And WebRTC is for peer-to-peer communications between two and multiple users. All right, so WebRTC has three APIs. Media stream. This is for acquiring media stream, meaning audio and video of your device. Okay. And RTC peer connection, this is for communicating audio and video. And RTC data channel is communicating data. Okay, so the first thing you have to do is to get the media stream object. And once you get the media stream object, then you can make a RTC peer connection for sending and receiving audio and video. And if you want to send and receive data, you can also create RTC data channel. Okay. All right, so let's do exercise 1. So exercise 1 is basically to see how you can get the media stream. Okay. Before we move on, we can actually try the WebRTC demo. So in fact, if you go to this website, applrtc.appspot.com, okay, you are actually connecting to this web server. And then you should be able to, in fact, the video communication. So you can see my top of my head, right? And you can actually copy this URL, okay? And then you can have another tab, and then add that one, okay? And then you can actually see, basically, you can you can see, basically I'm actually communicating myself. So, you can consider these are two different users, right? And yes, you can see this is me, and then this is my partner, in this case myself, is communicating. Okay, and if I go over here, same thing. I mean, you should actually see me and remote user. Okay, all right. Okay, so if I'm actually using this one with a different machine and with a different user, then I should actually see somebody else, right? Okay, so pretty straightforward. Okay, so that is the end exercise. And in fact, if you take a look at what's happening, you should be able to see, how things are done. Okay, so we're gonna actually try this one later on as well. Okay, so this is what's happening, and now you have two chatters to talk to each other. Okay, and then you can hang up. Okay, so let me hang up. What is hang up? Looks like this doesn't. I'm gonna just hang up like this. Okay, so that is exercise 1. Now let's actually move on to the next, media stream. So this is JavaScript object that represents your audio and video. Okay, and you get media stream object by calling get user media method. Okay, so let's see how that is done. So a media stream object represents a stream of audio and or video. Okay, it could be just video, it could be just audio. It's a combination typically, and it can contain multiple tracks. So typically it will have a one single, the media track and one single audio track. Okay, and so basically you can get this media stream object by calling get user media method of your navigator. Okay. All right. So this is the code. So you get the user media property first. Okay. And then, yeah, so let's actually take a look at this code first. So the way that you are going to call get user media is that you can specify what is called the constraint. So I'm gonna talk about it in a few seconds. And then you provide a successful callback and error callback. So successful callback, when getting media is successful, has been successful, this successful callback will be invoked with a stream object. So this stream object is representing the media stream object. Okay. So here I can actually assign to Windows stream property so that I can actually inspect it if I want to. And then I'm going to actually create I'm going to actually convert the stream object to the URL so that I can specify the URL for my video element. Okay, so I have a video element that is connected with the source. Okay, so basically I'm actually converting it to URL and then assign to a source property of my video object, and then I can call play method. Okay, on my video object. So basically it's just playing the what is actually seeing it from its video and audio. Okay, if there is an error, then this is going to be called. Okay, now in terms of constraint basically specify what you want to do with your how you want to actually get your the media stream object. So here what I said was I'm only interested in video. Okay, and I set the audio false, meaning I'm not interested in audio, I'm just interested in just a video. Okay, so this is the very simple code of getting media stream object. All right, so let's do exercise 2. So exercise 2 is, so you are going to run the HTTP server. So let's actually go to HTML5 and WebRTC and run HTTP server. So it's actually starting the server. Okay, and then we are going to run this code. So here is basically just getting the simple media the media stream object. Okay, so just click this one, and then it's going to ask you whether you want to actually allow this application to use your camera. Okay, again, the showing your the surrounding environment is actually privacy related issue, so it has to ask you to give you permission. So I say allow, okay, then it actually capture the screen. I mean, that my camera is actually being used, okay, to capture so that's basically what it's all about, okay. And so now if you actually click so this permission denied is when you are not actually accessing from the local server, this is what you get. So it's just a troubleshooting tip. So if you take a look at the code, this is index.html file. It's actually using the main.js file on the JS directory. Okay. So if you take a look at the main.js file, so it's basically using the same code that I've shown you in the slide. So it creates the constraints object. So I'm not interested in audio, so I say false, and but I'm interested in video, true. And then I'm just calling constraints with this constraint object, and then this is a callback function, successful callback function. So if everything is okay, then this callback function will be invoked, and I'm basically creating the URL, and then assign that URL to the SRC of my video object. Okay. So basically, the reason you have to call this one is I think in Firefox and Opera, the source of the video can be set from the stream itself. So for Firefox and Opera, you don't have to do this, but for Chrome, even actually current version of Chrome, I guess you don't have to do it. But yeah, so but just in case if you're using a little bit older Chrome, I guess you have to actually convert into a URL like using this call. Okay, so that is that, and now what we are going to do is we want to inspect the stream object. So we actually save the stream object to stream property of window, right? So we should be able to inspect it. So press F12 and then inspect it by saying console.dir and stream. Okay, so let me actually do that. So I'm going to just try this one again. Okay, this one again, allow it, and then I'm going to inspect it. So I should be able to inspect a console dir and now stream object like this. So now you can see it's a media stream type, right? Now in here it's actually for the prototype of the media stream, and you can see it does have a couple of methods that are interesting. One is get audio tracks, and the other one is a get video tracks. Okay, so we are going to actually call get video tracks and see what it returns. So we're going to say stream and get video tracks. Okay. All right, so it returns medium stream tracks. So if you actually see this one, you can see this is actually using my USB 2.0 camera. Okay, so let me actually move my machine because I'm running out of my battery. Okay, sorry about that. And let's try to get the audio track this time. So, because I have set the constraint not using audio, it should actually return null. So again, go to stream and get audio tracks. We are going to call the method. As you can see, there is nothing returned because we have set the. I'm going to just go over here. We have set the constraint without the audio. Okay, so that is basically what is happening. So we just inspect it. Okay, and we did the audio tracks, nothing. So now what you're going to do is we are going to modify. You are going to modify this one to true. Okay, so modify the code to true, and then refresh the page. And then this time, if you call the get audio tracks, it will actually return the audio object of yours. Okay, so try that. And the next one is using a bit more options in the constraint. So in this case, if you click this one, you can actually set the resolution of your video with high quality and VGA and yeah, so QVGA and VGA and the high definition. Okay, so if you say this one, if I allow it, it's going to use these things, and if I select any of these two, then it will use a different resolutions. Okay, let's see. So if you take a look at the code, basically, it actually have a different constraints. Okay, so this is a QVGA constraint and VGA constraint and HD constraint, and so let me actually show the code here. And depending on what you choose, it will use that particular constraint, and different constraint will basically use a different size, okay, of the video. That's all. All right, so I'm gonna actually have you guys to play around it up to that point. I'll give you about 10 minutes to try it. Okay. So let's talk about the concept of signal first. Okay. The WebRTC uses the RTC peer connection to communicate streaming data between browsers, meaning between peers. But before it does that, it needs a mechanism to coordinate the communication and to send some control messages. And this process is called the signaling. So they have to actually find each other first, and they have to exchange some, the communication, the capabilities, and things like that. Okay, these signaling methods and protocols are not specified by the WebRTC, so they could actually use the application. WebRTC application could use whatever messaging protocol they prefer, such as a SIP, XMPP, or even actually WebSockets. Okay. All right, now signaling is used to exchange three types of information, like a session control message, and network configuration, and media capabilities. Okay, so basically this information needs to be exchanged before they can start communicating. Okay. All right, so we're going to actually see some of these examples using the lab exercise. All right, so let's move on to the next API, which is called the RTC peer connection. So this is the connection that you have to create before you can do peer-to-peer media chatting, for example. So this peer connection, RTC peer connection, handles signal processing, codec handling, peer-to-peer communication, security, and bandwidth management. Everything is done by RTC peer connection. Okay, so you don't really have to actually get involved these things. These are all done by RTC peer connection underneath. So this actually architecture, this picture shows the RTC peer connection architecture. So your application is using RTC peer connection API. Okay. Underneath, it has the voice engines and video engines and transport. Okay, so as far as developer is concerned, we are just dealing with a very high level RTC peer connection APIs, and we'll take a look at that. Okay, so this is an example. So here you are going to suppose if you are starting to communicate with your peer, okay, and let's say this is called, and you are going to create RTC peer connection object first. Okay, and then what happens is that you are going to set on event handler called the ICE candidate. So basically what it does is that whatever network interface that your machine has will be detected, and that will be, once it is detected, it will be called. This function will be called. So this on ICE candidate is this event handler. In this case, this function will be called when the network interface of your device is actually found. Okay, and basically it does is, and once it is found, basically it's going to send the information about itself, like a codecs and things like that, to its partner, to its peer. Okay. On add stream is that so basically when the remote stream is received, then you want to actually set it to your stream. Okay, basically yeah, this code, you know what? I'm gonna actually use the hands-on lab to actually give you a sense of how this code works. You know, without actually showing you how things work first, it might be a little bit too difficult for me to explain everything. So why don't you actually do the exercise 3 first, and you know, let's see how this one works, and then I'll explain the code. So this is exercise 3. Okay. So basically, this is an application where again you are communicating to yourself. Okay. So here I'm going to call the this one. So here I can start the communication. So here, if I click this one, is asking me to allow the to use the camera. So I say allow. Okay. So this is you know, is peer number 1, me. Okay. Now I can actually create a call to my peer. Because these two clients on the same machine, they don't need to a server to actually kind of intermediate, you know, to let's say, you know, we don't need any intermediary, the player in this case, because these two clients in the same machine. So if I click call, then they are connected, okay, and then I can hang up, okay. Now in this case, what we are going to do is we are going to see, you can actually certainly see what's happening, okay. So I'm going to actually refresh the page to start from the beginning. So now if I actually click start is basically, you know, the creating, so if I click allow, it's basically requesting local stream and receive the local stream. It's basically the same code that we have seen in exercise 2, just getting a local stream object, okay. Now when I click call, it does a lot of things. Okay, so it does a lot of things, and basically, you know, it actually exchange information about itself. So this is in fact what is called the description. This description describes your codecs and all kinds of other information that they need to be in agreement with. Okay, all right, and then you know they are in. They should be in communication. So now I can actually hang up, and then. The connection is closed. Okay, so let's take a look at the code. So let me show the code now. So this is the description that is being exchanged. In this case, we have in fact the local. So this is local client and this is remote client, but they're in the same machine. So this is an exercise. You know, so I titled it as RTC peer communication without servers. Okay. The reason is because typically you are going to communicate. That you do not, you know, with someone else, right? That you know that someone else might be located 3,000 miles away. So in that case, you need the server to kind of bridge between the two users, okay, for communication. So in this case, we are just using the two users on the same machine. Okay, so let me actually show the code. Okay, so when the start button is clicked, it's basically getting the media stream object, as we have seen. It's just calling get user media with the constraint of the video true, and then it has a GutStream handler, and GutStream handler is just setting the URL to the SLC. Okay, so that local, as you know, the local video now actually have a stream of your local camera. Okay. Now, when you click call, that's the time that we are going to actually create WebRTC peer connection object. Okay, so here it actually calls the new WebRTC peer connection object. Now the servers is actually setting to null here. So you know the reason we are setting those servers to null is because we don't need servers to actually bridge these two users. They are actually sort of the known users, okay, because they are on the same platform. Okay. So we now have created a local peer connection, okay, and then for the event handler called the on ICE candidate, we are setting gut locate IC candidate. So basically, again, this IC local IC candidate is called this function. This function is here. This gets called when your system finds out the proper network interface on your machine. Okay, so from that event candidate, we are basically remote peer connection, add ICE candidate. So because we found the same candidate, okay, we are going to use the same machine, same, let's say, network interface in a sense. So we actually setting it for the remote peer connection as well. So in this sample application, we have a local peer connection and remote peer connection, and so they are actually representing the two different endpoints, so to speak. Okay. All right. So this gets called when it finds the interface. Okay. And then we are going to create the another peer connection. This is representing remote version of it. Okay. And then we have again got remote ICE candidate, so that gets called it's basically working in the same way. Okay. Again, this code is sort of the convoluted because we have both in the same code, both client and server in the same code. Okay. All right, so we actually set the local peer connection object and remote peer connection object, and then we have set the this IC handler. So basically, this gets called, to detect the network interface. Okay, and then we also actually add the add stream event handler, and that is basically got remote stream. So this, when we have received the remote stream, meaning this is actually representing the second user. This is representing second user. When the second user received the remote stream, okay, it will add it to this stream. Okay, and for local stream, it's gonna just add it local stream. Okay, and then it will call the create offer. So create offer means once they actually have agreed upon what network interface they are going to use, they are going to exchange their description. So that description is again what codecs they use and all that stuff. So that's basically this information. Okay, all right. So the that contains a lot of information. So it will actually send that information to so local peer will send it to the its own partner. So that is the remote peer connection, so to speak. Okay, and when so got local description is called when you receive the local description from its partner. Okay, and so it will set the description. And then it's going to actually call the it's going to also set the remote version of it, and then create answer is actually responding to the sender of that description. Okay, so that's basically what happens. So in order to have whole things to be communicating before you can see the video screen each other, you have to create the peer connection object. Then you have to find the local interface, network interface, and then you have to exchange description object by calling create offer and create an answer. So create offer is sending it. Create an answer is actually once it receives the description, it will send it back the response. Okay. Okay, so that is pretty much it. I felt like I didn't explain in nitty-gritty detail, okay? But as long as you got some reasonably, the high-level idea how things work, that should be actually good enough. So I'll give you guys about 10 minutes to do exercise 3. So RTC data channel is used to exchange data between peers. So in terms of API, it works pretty much like a WebSocket. The data will be secure automatically, and it could support unreliable and reliable communication depending on the need of the application, right? And I'm going to actually use, I'm going to actually use the lab documentation to show how the data channel is going to work to exchange the data. So once you got the peer connection, RTC peer connection, setting up the data channel connection is pretty straightforward. Okay, so we're going to actually do this exercise. Here we are going to start, and here we are actually sending some message. JPassion.com is cool, and we send it. And this receiver, receive it. Okay, and then we can just stop it, something like that. Okay, so if you take a look at the code, yeah, so you can certainly see the message has been sent, and then it also received the message. So the code is pretty straightforward. So again, it's actually inside the main.js file. So we created a connection. So this is actually RTC peer connection that we worked with before. When it's creating peer connection, you have to actually set the optional data channel equals data channel true. Okay, so basically when you're creating RTC peer connection, we also indicates that you're also doing data communication as well, setting this option. Okay. And then you are going to set you're going to create the send channel. Okay, so reliable data channels not yet supported in Chrome, so it's going to be unreliable. So you can set the reliable false or reliable true, and depending on whether the browser can support reliability or not, it will support it or not support it. Okay, so but for now we're going to just have an unreliable channel, and then we are going to have on close and on open and on close with event handler, and this is not that much things to do. I mean, this is basically just indicating that channel has been open so that you can send a message, and this is actually a handler just indicating that channel has been closed or something like that. Okay. And then we are going to set for remote connection. We are going to set the got receive channel. Okay, so basically got receive channel is going to just get the channel object, and then we are going to just set the handle message event handler. So whenever on that channel, whenever message is received, we are going to just call the handle message. And handle message is going to be just the display the message into that in the text area. Okay. So the APIs are actually very simple for data communication. Basically you got the data channel, and then you're going to just send it. So this is the way that you're going to actually send it. Okay, so this send data function is going to be invoked when the send button is clicked. Okay, so once the connection is created, then you can click the send button, and then it will just call the send method to send the data. Okay, and then the event handler message that actually received the message, which is this guy, a handle message. So handle message is the one that actually received the message and then just display. So very simple exercise. Okay. All right. So that is gonna be end of